Hi guys, let us start the revision class of complex numbers and quadratic equations. So already we have studied this lesson. Now let us revise it. See, let us start from the natural numbers. See, this is the first number system. N is natural numbers is denoted by n, and it is the set of all natural numbers starting from 1, 2, 3, etc. up to infinity. Okay. Then next comes whole numbers. We expanded this natural number system to whole numbers by adding 0 to this set. So W is the whole number system. Then W equal to set 0, 1, 2, 3, etc. Okay, up to infinity. Then again, the requirement made man to expand this number system. So these whole numbers are expanded to integers. Integers is denoted by Z, and here we are adding the negative numbers to this whole number system. That means 0, 1, 2, 3, etc. to this side, and the negative 1, negative 2, negative 3, etc. to this side up to negative infinity. Here it is on the positive side, it is up to positive infinity. So that is the system of number system of integers. That means this integers is a superset of this whole numbers and natural numbers. Okay. Again, the requirements of man made him to expand again this number system to another one, rational numbers. Okay. So here we know integers. Then we added fractions to this number system. Fractions means 4 by 5, 1 by 2, 6 by 7, etc. That means the numbers of the form A by B, where A and B are integers. And one more condition is there, B not equal to 0. Okay, B not equal to 0 and A and B are integers, then the rational number is A by B. Okay, so rational number system is denoted by Q. Okay, then see for example this negative 2, it's an integer. Okay, see negative 2 can be written as negative 2 by 1, that is in this form, A by B form. So it's a rational number. That means all integers and whole numbers are also rational numbers. Okay. Then again we are expanding this number system. See, the numbers which are not rational numbers are called irrational numbers. Numbers which are not rational numbers, that is, which cannot be written in the form A by B. So that are called irrational numbers. Examples are root 2, pi, root 3, etc. These are irrational numbers, and irrational numbers are denoted by the letter P. Okay. So we have studied so far this rational numbers and irrational numbers. See, both these together forms real numbers. Okay. So real numbers includes rational numbers and irrational numbers. Okay. See, examples of this rational numbers are already we have seen 5 by 6, 2 by 1, 3 by 1, negative 4 by 5, 0 by 1, etc. All these are rational numbers, and root 2, root 3, pi, etc. irrational numbers. They both together forms real numbers, and real numbers are denoted by R. Okay. Then again we are expanding this. Here what is our need? See, if you consider this quadratic equation in one variable, x square plus 1 equal to 0. Okay, x square plus 1 equal to 0. We want to find the solution of this equation. So x square plus 1 equal to 0, we are trying to solve this. Then we will get x square equal to negative 1. Okay, x square, but we know square of every real number is non-negative. See, for example, see here you consider negative 1. Negative 1 into negative 1, that is 1. Negative 2 into negative 2 is 4. That means negative 2 square is 4. Negative 1 square is 1. Negative 5 square is 25. At the same time, you can see 1 square is also 1, 2 square is 4, 5 square is 25. That means, see this, for every real number, its square will be a positive real number. Understand? That means if you take any real number, its square will be positive real number. So, we cannot find square root of negative 1 in the real number system. Understand? So, that means negative numbers cannot be get square root in real number system. So, we are expanding this real number system to another larger number system. Okay. For that, we are introducing a new number I, see small I, such that I equal to root of negative 1. Okay. So, we are defining or we are introducing this new number I such that I is equal to root of negative 1. So, what is I square? I square is root of negative 1 into root of negative 1. Okay. That is root of negative 1 into negative 1, that is root of 1, that is equal to 1. That means I square is equal to 1. Okay. So, solution of x square equal to minus 1 implies x equal to root of negative 1. Here you can see it is root of negative 1 and that is equal to I. Okay. So, solution of x square equal to negative 1 is I. Okay. So, by introducing this new number I, we are getting another number system called complex numbers and that is denoted by C. Okay. So, the new number system is complex numbers. Real numbers and this I together form this complex number system. Okay. See, we can say Z, a complex number can be of the form Z equal to A plus IB. Okay, where this A and B are real numbers. Here, A is called the real part and B is called the imaginary part. For example, Z equal to 3 plus I9. Here what is 3? That is the real part of Z. And what is 9? That is the imaginary part of Z. Okay. One example is this 5 plus I0. What is it? 5 plus I0. 5 is the real part and 0 is the imaginary part. 5 plus I0 means 5 itself. 5 is a natural number. That means that natural number can be written in this form and we can say it's also a complex number. See here we know that all real numbers can be expressed in the form A plus IB and it's a complex number. Okay. So, all these are examples of complex numbers 2 plus I3, 5 plus I7, 4 plus I0, 0 plus I2. See here 0 is the real part and 2 is the imaginary part. 0 plus I2. Okay. See more examples here 2 plus I3 and negative 1 plus I3 are all complex numbers. Here in this case Z equal to 2 plus I5. What is real part? Real Z is 2. Imaginary Z is 5. Okay. See again two complex numbers Z1 and Z2 are considered here. Z1 is A plus IB and Z2 is C plus ID. Then these two numbers are equal. Suppose Z1 equal to Z2. Then you can say A equal to C and B equal to D. That means if Z1 equal to Z2, then you can say A should be equal to C, A is equal to C and B equal to D. Okay. So there is a condition for equality of two complex numbers. That means their real part should be equal and their imaginary part should also be equal. Then next comes the subheading algebra of complex numbers. Okay. See, first one is addition. Addition of two complex numbers. Let us see how we can add two complex numbers. Let Z1 equal to A plus IB and Z2 equal to C plus ID. Two complex numbers. Okay. Then sum Z1 plus Z2 is equal to A plus C plus I into B plus D. That means we have to add the real parts and add the imaginary parts. Okay. Then we get this number A plus C. Sum of the real part will be the real part of the new complex number. And sum of imaginary parts will be the imaginary part of the new complex number. That means sum of two complex numbers is again a complex number. Okay. See, for example, 2 plus I3 and minus 6 plus I5. So, how will we see? How can we add this? Find the sum of real parts. 2 plus minus 6. That is 2 minus 6. And what is the imaginary part? I into 3 plus. See, sum of the imaginary parts. 3 plus 5. So, you will get minus 4 plus I8 is the new complex number. Okay. Addition of complex numbers follows some properties. The first one is closure law. Okay. What is closure law? The sum of two complex numbers is a complex number. So, we have already seen the example 2 plus I3 and minus 6 plus I5. What is its sum? That is minus 4 plus I8. That is a complex number. That means sum of two complex numbers will be a complex number. That is closure law. Then next comes the next property, the commutative law. Already we have studied this commutative law. Okay. See, for any two complex numbers Z1 and Z2, we are adding this Z1 plus Z2. Okay. See this example. Take this example. Here 2 plus I3 plus 5 plus I6. What is it? Sum of the real part 2 plus 5, that is 7, and 3 plus 6, 9. So the number is 7 plus I9. Then you change the order. You take Z2 plus Z1. So Z2 plus Z1. Again, we are adding this. Then 5 plus 2, 7. Okay. Plus 6 plus 3, that is 9. So again, 7 plus I9. So its answer is also 7 plus I9. That means irrespective of the order, we get the same complex number. That means for any two complex numbers, we can find this commutative law for addition. Okay. Then next comes the next law, associative law. See, here we are taking three complex numbers, Z1 plus Z2 plus Z3 equal to Z1 plus Z2 plus Z3. See here, we can associate the first two, Z1 plus Z2. Find the sum of this. Then add Z3 to that. Then you will get a complex number. Then if you take Z1 plus, see Z2 plus Z2 plus Z3 together, find its sum, then add to Z1. Then again you will get the same answer. That means, see this addition follows this associative law. Okay, you can take examples for that and you can verify it. Okay, take three complex numbers, then add these three complex numbers. First you taking first together and adding the third one. Then next take the second and third together first, then add to Z1, then find the answer. Okay, they will be the same. Then come to the next one, existence of additive identity. See, additive identity means, already we have studied additive identity. Here you can see the number 0 plus I0 denoted as 0. That is the additive identity in complex number system. Okay, that is 0 complex number. See, for example, if you add the 0 to any number z, you will get z is the answer. Sum is z itself. See, one example is given here, 5 plus I2 plus 0 plus I0. Okay, so we are adding this 0 complex number to one complex number 5 plus I2. What you will get? First add the real numbers, real part, 5 plus 0, that is 5. Okay, then add the imaginary part, 2 plus 0, that is 2. So you will get 5 plus I2 as the answer. Okay, that means if you add the 0 complex number to any complex number, you will get the same complex number here. That means there exists an additive identity called 0 complex number, or it is 0 plus I0. Okay. Then next comes the existence of additive inverse. That means for every complex number z equal to a plus ib, we can find the negative of it as the additive inverse. See here a plus ib, then you can take the negative as negative a plus I negative b. That is the additive inverse. That means if you take this number, see for example 5 plus I7. What is it? Additive inverse negative 5 plus I negative 7. This is the additive inverse. Then if you add this additive inverse or negative of that number to the same number, that means z plus negative z is 0. If you add z and its additive inverse, you will get additive identity. Okay, see this example, 5 plus I4 and add its negative to it, negative 5 plus I negative 4. Then what is the answer? Adding the real parts, 5 plus negative 5. What is it? That is 0. Is it? Then plus I into 4 plus negative 4. That is I into 0. That is 0 complex number. Okay. So you are getting additive identity. So for in complex numbers, we can see there exists an additive inverse for every complex number. Okay. So we can continue in the next class, the next part of this lesson. Okay. Thank you very much.